Hello everyone, my name is Yogesh Girikumar. I work for Humanitarian Openstreetmap Team as a solutions architect. I take care of generally the site reliability functions, and I'm also the DevOps engineer there. Brief about Humanitarian Openstreetmap Team. It's an international non-profit NGO. It's dedicated to humanitarian action. It's focused primarily on open mapping, meaning it engages volunteers around the world to map areas that are at risk of, let's say, some climate or conflicts related disasters, and it pushes the data to OpenStreetMap. So here's the impact report if anybody is interested. It lists all the positive impacts that OpenStreetMap and Humanitarian OpenStreetMap specifically has had over the last year. An introduction to Tasking Manager. It's the flagship tool of Humanitarian OpenStreetmap Team. It's a tool that usually is used to help crowdsource map data onto OpenStreetMap. The gist of the tool is to take an area of interest, split them into grids, and each grid is assigned to a volunteer mapper with instructions. And after the volunteer mappers complete the single cell that they are assigned, it will be validated by validators, and the data will be uploaded to OpenStreetMap to be available to the general public. Tasking Manager's tech stack is fairly straightforward. It's a React-based front-end and a Python-based back-end, and it's got PostgreSQL for its database needs. Currently, the Tasking Manager is, at least the hot Tasking Manager is hosted completely on AWS. We'll see what the services that we use for getting the Tasking Manager up and running on AWS in future slides. So the current infrastructure is fairly straightforward. We have VPC on AWS on which the backend is hosted along with the database. They are of course separated with subnets and network access control lists. The front end is hosted on S3, which is like a more or less a serverless object store on AWS, and it's served using a CDN that's also provided by Amazon. It's called CloudFront. The backend EC2 instances are auto-scaled using auto-scaling groups, and we use the standard Amazon RDS for PostgreSQL needs. The way the control flow works is that somebody logs in to Tasking Manager using their OpenStreetMap credentials, and then uses the Tasking Manager uses OAuth to keep the session active. And once the user is authenticated, then the map reads and writes happen directly from the backend to OpenStreetMap. All the deployments of the infrastructure, including every instance, every bucket, everything is done using AWS CloudFormation, which is an infrastructure as code service that AWS offers. Currently we use New Relic for application process monitoring. We use Sentry for traces, and use CloudWatch logs for exporting application logs, traffic logs, and all of that. We also have CircleCI, which acts as the deployment pipeline. CircleCI takes in CircleCI basically is a wrapper around CloudFormation templates. So CircleCI simply runs the CloudFormation templates, which basically launches the stack. For backups, we have some scripted database backups in addition to standard RDS snapshots that are scheduled to run several times a day. So there are several challenges that come with this legacy architecture. It's firstly expensive. It's fairly rigid in its capacity. So while the backend auto scales, it's quite slow. It bootstraps quite slowly. It's the size of the backend EC2 instances is hard-coded into the CloudFormation template, and our RDS is scaled up on demand, but not scaled down very easily because it does not handle load very well scale down even if it did earlier. So that's an engineering issue that we've been grappling with. We also have a few deprecated services that support the Tasking Manager architecture. Specifically, we have AWS Launch Configuration, which has since been replaced by AWS Launch Templates, but that's the way it is at the moment. We have other challenges, so changing the infrastructure is not the easiest. We have to change CloudFormation templates, which is not the simplest to grasp. We have our deployments are slow because CloudFormation templates have to be signaled by the auto-scaling group that all the instances are ready, and it's just generally slow to bootstrap, and that delays things further. And it's not quite straightforward to patch things, so we can obviously change the AMI ID in the CloudFormation template, but it's been difficult because of the legacy applications, legacy Python versions and Node versions that we have so far used, which we fixed recently. And the tooling that we use for observability and managing the infrastructure and the deployments they're all generally fragmented all over the place. So one of the focuses for HOT is to unify the tooling and make sure that it's well documented. So on to the improvements. We've been working on using serverless to services wherever possible. So for the front end, we use AWS Amplify. AWS Amplify is a tool that can both build the front end static site and deploy it to CloudFront Edge, which is a CDN on Edge service that AWS offers. The backend has now been containerized, meaning that it now runs on AWS ECS, and that's faster, much faster than EC2 instances. And we can also do updates to the image quite quickly using the same CI pipelines we use for deployment. And we also have better tooling for security. For example, we've been using HaloLint to lint the Docker files, and we've been using automated security scanners to scan our container images to see if there are any security issues that need addressing in the immediate term. We also have sidecars for monitoring the application. So we have a Neuralink sidecar that would ingest data and then send it to Neuralink. And we also have, we also took a lot of time and effort to improve the VPC architecture, and more on what that entails in the next slide. But overall, this has led to a lot of improvements. We embrace serverless. One of the primary advantages for us, specifically, more than performance, is cost. We have managed to bring down cost a lot because, especially for RDS Aurora, we can start at 0.5 APUs or Aurora processing units, which is the lowest amount of processing that Aurora can spare, and it can scale up to 16 or 32 APUs. So when there is no load, there is no manual intervention required to scale the database, so the cost is fairly under control. We also have really fast service scaling because of ECS. ECS is also behind auto-scaling group, and it uses traffic load and CPU load to determine when to scale up and when to scale down. We have better networking features as a result of VPC architecture overhaul. So all our applications are IPv6 compatible. Our subnets that we use to store, subnets we use to host our RDS, and subnets we use to host our backend infrastructure, they are tightly restricted using security groups and network access control lists. So we recently moved to using Debian Bookworm for our backend, and that makes things much better in terms of security, and we can also keep the size of the container relatively light, and it's fairly easier to patch the containers when security updates are available. And this is the production infrastructure, but because the backend is containerized, we can also quickly spin up out of AWS or even within AWS containerized tasking manager instances that are ephemeral, that developers can spin up and spin down whenever they want. Whenever they make a change, they can simply spin up a containerized tasking manager with their changes to test their changes. So that's actually improved developer productivity massively. We also have a renewed focus on our internal SLOs and SLIs, and we have the improvements to them and like slightly better thought out SLOs and SLIs have basically given us a good idea of what to expect in terms of performance and how to where to prioritize in terms of performance optimizations. We also have slightly tighter error budgets that we don't meet them all the time, but we are making good improvements to make things better there. Just a note on developer experience. Because of the ability to spin out ephemeral tasking manager instances, developers are now, it's become easier for developers to test out the infrastructure themselves without affecting the staging instance or the instances that other developers use. So collaboration and the ability to like quickly and cheaply bring up and bring down instances have become better. We also have focused on continuous deployment in addition to continuous integration. There is an adage that's on the rounds recently, that if you don't have continuous deployment, then there's no point in continuous integration. And I tend to agree that continuous integration, I think, should organically lead to continuous deployment. So I think there is a lot of benefits to be reaped by investing in, some time in trying to understand the deployment environment and making sure that continuous deployment is in place. As for observability metrics, we have been looking at averages in general. We also thought that we should look at better metrics in terms of, for example, percentiles. So that has also improved our understanding of the application's performance as a whole. And because we have faster bootstrapping services, we don't get as many false negatives from our alerting systems, which is currently Genie and Slack alerts and other systems including AWS SNS, email notifications. So that has massively gone down for tasking manager, and that's actually, there was a pleasant surprise. It was an unintended side effect, but most welcome. And then this has actually made it easier for developers to focus on other important things rather than wrangling with the infrastructure. It's become easier for us to review, peer review community contributions and get them in and quickly test them and give them comments or notes on what to change or whether or not there is improvement to be made in a particular change set. So, because of the nature of funding of HOT, our cloud bills are mostly paid for by grants that we receive from Microsoft and Amazon. And when we experiment a lot, when we bring up and bring down instances for developers, when there are a lot of ephemeral instances of tasking manager, and when we are trialing when there is trial and error when it comes to trying out different strategies and architectures, grants tend to dry up really, really fast. So we have to keep that in consideration when we deploy our application. So the earlier wisdom was that we cannot get locked into services that are specific to one cloud vendor or the other. For example, let's say we use AWS Lambda or AWS SNS or anything really that has an analog in other cloud providers but not really easily portable, then that's always been a problem. We have a better idea now about how to handle it. It takes a lot of time and effort, but I think in the long run it will benefit us in a way that we can handle. So we have to balance and juggle between cost and performance and flexibility of the application deployment. So we started using Terraform. So we have now a Terraform module for Tasking Manager that deals with AWS, and there are a few modules for dealing with Azure. And these modules make it super simple to deploy the application on either AWS or Azure. And the only problem that we are left to deal with is to move the data from the database, which is currently at 1.2-ish terabytes. So there has been several lessons that we learned, including things about cloud vendor lock-in and things about performance and how to deal with developer fatigue in general. So I think this exercise has been really useful in actually getting a better understanding of Tasking Manager itself, and including how to better manage deployments when cost is a constraint that other people usually don't have when they speak about fancy tooling and pipelines to deploy. So thank you, that's my presentation.